Hello everyone, and welcome to another episode of BMED 202. In this episode, we will be looking at moment of a force. Now, what exactly is a moment of a force? A moment of a force is the measure of the force's tendency to cause a body to rotate or bend. And this tendency is affected by the distance of the force from the point of rotation, meaning the force that will be required to rotate a body will be dependent on the distance of the force from the point where the rotation will take place. Now, let's look at this spanner. There is a force being applied in an attempt to rotate the spanner, and the point of rotation is noted by the center line right in the center of the knot that the spanner is attempting to rotate, and the distance of the force from the point will determine the magnitude of the force that will be required to successfully rotate the spanner. Now, as it relates to moment of a force can be positive or negative, and that positive or negative sign can be determined based on the direction of rotation. If the rotation is a clockwise rotation, the moment of that force at that particular pivot point will be considered to be positive, while if the rotation is negative, meaning if it's in a anti-clockwise direction rather, the sign will be a negative sign. Now let's look at these four examples. In the first example, the force is a downward force, and it is to the right of the pivot point. Therefore, a clockwise rotation will occur. This moment of this force will be considered to be positive. Likewise, for situation D, if you notice, even though the force is on the opposite side, meaning on the left, the rotation is still positive due to the fact that the force is pushing upwards. Now, if you look on scenario C and the scenario B, you will realize that given the direction of the force and the side that the force is on, the rotation will be an anti-clockwise direction rather, and this will result in the sign convention being negative. Now let's look more closely on how moments of a force work. When we are calculating the moments of a force, we are simply multiplying the force by the distance, and the units for that would be Newton meters. So since force carries a unit newtons and distance carries the unit meters, the result would be Newton meters. For example, if 5 newtons of force is applied 4 millimeters away from a pivot point, the moments at that point will be 20 Newton meters. Let's look at another example. If the force acting on the body is 20 kilonewtons and it is acting at a distance 3 millimeters away from the point of rotation, the moment that is determined will be 60 kilonewtons, or 60 kilonewton meters rather. So it doesn't matter what the units are as long as it's a unit of force times a unit of measurement. Now, how does moments work? Let's present a real life scenario. Let's say I'm attempting to turn this spanner in a clockwise direction, and I'm applying the force 2 newtons at a distance 30 millimeters away from the pivot point, I can determine the moment of this force from that point. Well, let's say we needed a moment of 120 Newton millimeters in order to turn the spanner. Let's see if I can achieve this by adding this force at that particular distance. Now, in calculating the moment, as I said before, it's force times distance. Sorry. So let's see what will happen. That's 2 newtons times 30 millimeters. The answer will be 60. And it simply means that the force exerted is not enough to turn the spanner, given that I need a moment of 120 Newton millimeters. Now, there are two things that I can do, and the first thing that I can do is amplify the force, meaning apply more force. And in this case, if I apply twice the amount of force, I can now get the required amount of moment to turn the spanner. So 4 times 30 will give you 120. Now, that's the amount of moment that I need. There's another way that we can achieve the same result. Rather than increasing the force, we can increase the distance. Now, this will result in us carrying out less, or putting out less effort rather, to achieve the same result by simply moving the distance further away from the center point or the point of rotation. Let's work that out to see what the answer will be. So it will be 60 times 2. So that's 2 newtons times 60, and the answer will be 120 Newton millimeters. So that's basically how moments work. If you learned from this video, I urge you to share so that others can learn as well. Please like the video and share the knowledge. Have a good day.